This is Mr. Brook, and I'm going to be giving you guys the notes today for Monday, the 20th of April. We are going to, I'll probably do these from here on out myself. We'll try to keep them to 10 minutes or so or less, and then it'll kind of cover what we need for that particular day. So there are a few things I want to go over again with exponents, a couple things I want to just clarify, and then we're going to add a couple more rules that we didn't onto the ones that you guys did on Thursday. So first, when we're dealing with exponents, the x is our base, and the 4 is our exponent. All right, we can rewrite this as x times x times x times x. All right, it's to the 4th power, so there are 4 x's multiplied by each other. One thing I want to clarify and make sure that you guys know is the exponent if you just have an x. So if it's just x by itself, there is a hidden 1. All right, so the exponent, the power of this, it's x to the 1st power. All right, we'll look at a couple of exponent rules. The first one is the product rule. You guys did this one a little bit on Thursday. So if you have two things that are multiplied together with exponents, as long as they have the same base, you add the exponents. So x squared times x to the 3rd, 2 plus 3 is 5, so that's x to the 5th. Okay, quotient rule. So if you're dividing with exponents, you subtract them as long as they have the same base. So 7 minus 3, we're dividing, so 7 minus 3 is 4, so this ends up being x to the 4th. All right. A new one is the power rule. If we have something with exponents and we raise it to another power, that we multiply those exponents. So one thing that we could rewrite this as x squared to the 3rd power would be x squared times x squared times x squared. All right, so you could do that, add the exponents up, but it's simpler to say x squared to the 3rd power, multiply 3 times 2 is 6, that equals x to the 6th. All right, rule 4. If you have a product in there, if you have two things multiplied together and you raise x times y to the 2nd power, you can distribute that squared to both pieces. So this would be the same as saying x squared times y squared. So we cannot add these two exponents together because they don't have the same base. It's x squared and it's y squared. Rule 5, I think you guys looked at this on Thursday as well. If I have something to a power that's a fraction, I can distribute that to both the top and the bottom. So this would be x to the 3rd over y to the 3rd. We probably will not use a whole lot of those. It's just kind of there for your reference. Okay, another new one, the 0 exponent. If I have something to the 0 power, it equals 1. So x to the 0 power equals 1. Y to the 0 power equals 1. Anything to the 0 power is equal to 1. And 7, you guys looked at this as well, negative exponents. So if I have x to the negative 2nd, you guys did this on Thursday, you can pull that down across the fraction bar, 1 over x squared. All right, now combining a couple of these rules, we're going to look at some example problems and do some that are a little more complex. Now, the key thing, keep your numbers, treat them like they're normal numbers. If I have 2x squared times 3x to the 3rd, 2 times 3, they're just numbers. that's just 6. And then x squared times x to the third, that's multiplying, that's the product property, so 2 plus 3, that's x to the fifth. All right, number 2 is like the quotient rule, dividing 4 divided by 2. Treat them just like normal numbers, that's 2. Then x squared divided by x3, 2 minus 3 is negative 1. We write that as 2x to the negative 1. But since there's that negative exponent, we're going to bring that below the fraction bar. That negative 1 only applies to the x, does not apply to the 2. So this will be 2 over x. Pull the x down. All right, number 3. We have something raised to a power. So we're going to distribute that power to both things. All right, 2 to the second power. And then since it's x to the third squared, we're going to multiply those. 3 times 2 is 6, x to the sixth. You can simplify this further. 2 squared is 4, so 4x to the sixth. All right, number 4, we have this big old mess in here, but notice it is raised to the 0 power. Anything raised to the 0 power makes it 1, so the answer to that one is just 1. All right, now number 5, when we look at that, remember to keep numbers. So when we look at the number, keep the numbers together, treat them normal like you normally do. 2 times 2 gives us 4. Now you have to pay attention to what has the same base, x to the third and x to the negative 1. Since we're multiplying, add the exponents. 3 plus a negative 1 makes 2, so 4x squared. All right, then we have y to the negative third and y to the third. 3 plus negative 3 is 0, so it's y to the 0. We can combine this and do one more step. Anything to the 0 power is 1, so this is just 4x squared because this becomes 1. All right, number 6. 4 times xy, all to the negative first power. We can distribute that negative 1 through to everything. So 4 to the negative 1, x to the negative 1, y to the negative 1. Now we want to get rid of all of our negative exponents, so we can pull those down across the fraction bar. Since it's a negative exponent, that's the same as 1 over 4xy. Each one would get pulled down across. All right, and number 7, a nice big mess. So 2 and 3, 2 divided by 3, we're not going to do anything with that. We're just going to leave it in its fraction form. So 2/3. All right, we have x to the fourth and x squared. We're dividing, so 4 minus 2 gives me 2. So this will be x squared. Since it's x squared, it'll go up top. All right, then we have y3, y to the third, and y to the fourth. 3 minus 4 is negative 1. Since it's a negative 1, it will go on the bottom. So y to the 1. And last we have z squared over z. Z squared over z, 2 minus that hidden 1. 2 minus 1 is 1. So it's positive, it goes to the top. So 2x squared z over 3y.